Hey guys, it's Jam. I'm going to give you a quick overview of my chia farm. I'm currently in the middle of replotting for, I think, what is the third time. I replotted for plot NFTs and then Blade Bit, and now I'm replotting to Gigahorse C18. Um, People try to make this a lot more confusing than it has to be. Obviously, I have a decent setup, and I want to walk people through kind of what I'm doing. I benchmarked quite a few cards and looked through a lot of the data on kind of the best ratio for compute and decompression. And yeah, I'd like to share kind of some of what I'm doing, some rationale behind some of my thought process. So this is it. This is my little Chia dashboard. You can see my total effective space is 16.2 petabytes effective, total raw space 10.8. I think I have 11.3 petabytes raw, so there's currently some of the plots that got deleted that are making space for new plots. Again, this is just the standard dashboard that we put together for the the V2 version of the harvester, which allows you to remotely get all the harvester information just by running Chia Exporter on the farmer. And one of the things we put in there was this compression ratio breakdown. So right now I have about 4.6 petabytes of C18, 3.4 petabytes. This is Bladebit C7. This is 1.7 petabytes of Gigahorse C8, and then this was I think Bladebit C5. So you can kind of see here how much capacity I have on each harvester. I would not recommend this setup. What I did, I basically tried to consolidate all my storage into these two racks. There's a few more things that aren't shown here. I have one more JBOD and then a couple just desktops that I have laying around for doing the decompression. But eventually I'll have everything nice and cleaned up in these two racks. But you can see I have these 6 JBODs. Right now they're all just locally attached to this plotter. And yeah, again, I would not recommend this. You can see this is this .14, this rack here, and you can see I have like 2.29 petabytes of C18, 3.34 petabytes of C7, and 1.7 petabytes of C8. So there's a lot, way too much storage on this one harvester, which you'll see when we go to the latency is certainly 8 seconds average latency with the 4-second standard deviation is a little high, a little on the high side. Just so when I don't have time to redo this now, but eventually I'll kind of move it probably to 3 JBODs is probably the right ratio for each harvester. This is my 2.16 petabytes in a single 4U chassis, and this says Seagate 106, and then I have an AIC JBOD here, and these are just two Lenovo P620s Threadripper Pro. You can get the amazing deal on eBay right now for like $1,000, and then you just upgrade the RAM to 256, and you can see, plot time. This one has two 4070s in it, and the plot time is about 53 seconds. And then this one has two 3070s in there. Plot time is about 60 seconds. So two Gen 4 cards on Gigahorse is going to be kind of the best plot time. Now, I was doing that and doing a remote decompression, and then I'm using the remote decompression for another farm right now. So I currently actually swap back to just plotting on one of the GPUs and farming off the other, and the plot times are like 70-80 seconds, so it's still perfectly fine. Yeah, so with that, you can see one of the cool things that I can do is I can kind of look back over 7 days, and you can see I had to restart the harvester here at some point, which I'll kind of explain why. But you can see here in the last 7 days, I have plotted this C18 difference. You can see I've plotted 935 terabytes, and you can see I've reduced my plot size of C7 and C8. So what I am doing personally, I have 3 screens running for plotting. It's really easy. So I have one called plot, which is just running Gigahorse. So if you look at plot, I'm just running my Gigahorse, and you can see the plot time, total plot creation 89 seconds. This is the 3070, and then I have another one called sync, which is just running plot sync. This is very, very easy. If you guys don't know, in Gigahorse you can just go to this in plot sync right here. You can just run the Linux x86. You can just run this Chia plot sync with. I just run it to all of Dash Farm. So if you can see, I just have everything mounted to /farm. And it works out. We'll move this over here a little bit. Yeah, it works out really easy. So you just basically you just run plot sync in the background, plot to the plot sync as your destination, and then I have this other script called prune in the background. And what prune does is basically just deletes plots that are below older than a certain date and below a certain seed level that you'd specify on. And you just target a number of plots per day, it deletes, and it goes and deletes them. So there's basically two ways to replot, right? One of the other methods I use, which is a little bit cleaner, but you sacrifice a little bit of space, is you can unmount the drives, and then I have a script that just go back and format them, and it would go through and do like 5 drives a day, or 5 drives every couple of days, however long it took up to fill the 5 drives, and then remount them. And the script was just causing a lot more chaos than it needed. But that is the cleanest way to replot. That way you have drives that are formatted fresh, and you don't have any fragmentation. These are SAS drives, so I'm not worried about the latency while deleting the plots, and replotting is perfectly fine. But on SATA, you might see a little bit more weirdness. But the script is straightforward. I did post it on my GitHub, and I'll post a link here. And it's just called prune. And so this was literally ChatGPT wrote it for me in 30 seconds. So there's no like master wizardry behind this. I just told it, hey, this is what plot files look like. This is, again, I'm sure Python people are going to look at this regex and tell me I'm crazy, but it does work. So you basically just set a threshold date and a max compression size, and tell it how many plots a day you want to delete, and it will go through every hour and just start deleting plots. And again, this was just my super simple way of kind of dialing in, okay, how much, how do I do this replotting? So you can see it before I kind of tried to dial it in. My first shot was actually pretty close to where, I'm basically plotting my new plots per day. I think at one point it was like 175 terabytes a day with these two plotters, 160 terabytes a day or something like that. You can see if I go over like 24 hours, I've plotted 127 terabytes. Now I'm only using a single GPU in each of these plotters. So, each one is, about 60 terabytes a day. But I certainly could throw more plotters at this and make it go faster. Right now, I have some other stuff going on in the colo for some other projects, and I'm using all the power there, so I don't want to go over the max power. So I've kind of just left it at these 2 plotters for now. And so when I'm all done, when this farm is all the way at C18, it will be at 70% ratio. So 11.3 petabytes times 1.7, which is, let's see, 11.3 petabytes times 1.7. So I should be at 19 petabytes effective when I'm done replotting, and it should say 70% more space here in the dashboard. I am tracking this. As you can see, I currently have 16.2 petabytes. This is on 2 plot NFTs. This is one of them, one of the new ones, and it seems so I'm not missing any partials. I set it to the lowest, right, which is I believe 145 partials a day, which is kind of the lowest ratio in Space Farmers. I checked this versus the plot NFT show and plot size, and my 24 average is like spot on. Again, so Space Farmers, I could dial up the partials and send more partials, and I get a more accurate view over 24 hours, but then I would be spending more on decompression. GigaHorse has this really nice, basically this remote decompression, Chia remote server, which is really, really amazing. And here in the package here in Chia, GigaHorse, in Chia POS, they have this Chia recompute server. So it's really, really, really easy. You just run it on another host, and then you point your target at it with an export command, and that's all on the GigaHorse repo and how to do that. This is just this is a 3090 that's doing some decompression for one of the other farms, but you can see here over like 12 hours I can look at the average utilization, look at the average power, make sure things aren't getting completely out of whack, and it's just super nice to be able to. I'm running if you want this script, I put this in monitor GPU in my compose file, so I have this is the NVIDIA exporter here, and you can do a page for that, and I have it with my standard node exporter stack for all things, basically telemetry on my servers. So yeah, like I said, that's it. 11.3 petabytes. I have some other farms that I help out with and manage, and that's a lot of also consumes some time. I have some of my friend's stuff in the rack next to it. I have other fun crypto projects that I can't talk about yet, but hopefully this is helpful. Yeah, again, I think I've seen a million different replotting scripts, and again, so you have to remember when Max was replotting, he was using Chia Plot Sync, and so what he did was basically just that's why Chia Plot Sync was kind of written for his flow. He would just format all the drives at once, and then run Plot Sync to all the drives at once, and then just farm, do the plotting, and then point it at the IP address of the harvester that's running Plot Sync. That's a great way to do it because it works great. I also use Plow on my other farm. We have a nice little Ansible setup with Plow, and so yeah, there's a bunch of different ways you can do it, but this is how I'm currently doing it, and it's running. It's been running for I believe I had to restart it. You can see I think it by default only stores 15 days right now, but you can see in the last 15 days I have plotted 2 petabytes, and yeah, it's been going very, very steady up. It hasn't hiccuped once. I had to basically change some settings on the harvester because I mentioned, not really recommended to use this many drives per harvester. You just start running into all kinds of weird latency issues and hunting for bad drives and all kinds of stupid stuff that is really not very fun when you have this many JBODs in a single harvester. So I would not recommend this, but that was a setup. I thought I would try this for the replotting to make it super easy and set it and forget it. So I'll probably, after the replot is done, I'll probably tweak these and maybe change around the settings or something. And all right. One last thing. So a lot of people are like, okay, well, I don't have the right GPU for decompression, or I don't know how, I don't want to add any power to my farm. One option is to go to RunPod, and if you go into RunPod, or Vast.ai is another one. You can look at the pricing for these workloads. It's basically, you can take, so GPUs that are really good. I benchmarked a lot of GPUs for Chia, and 3080 Ti and 3090 can farm about 5.5 petabytes of C18. Pre-filter, so in July it'll go down, or June next year, whatever, it'll go down to half that. The other one, 4070, surprisingly good. I think 4 petabytes on a 4070. And so you can look here through some pricing. A 3090 is 44 cents an hour. If you go to their community cloud, 4070 Ti, 25 cents an hour. That a single 4070 Ti can farm, I think probably 4 to 5 petabytes of C18. So if you don't have a GPU, obviously, if you're farming 4 to 5 petabytes, you're getting a lot more rewards. So paying $100 a month or whatever for GPU is totally worth it. I did write, and maybe that's a time for another video, but I wrote a Docker script that will do all the decompression and everything remotely through a RunPod instance, and just using the GigaHorse Docker and kind of modifying it a little bit. It was super easy. I had it up and running with the remote IP, and I didn't even have to do any port forwarding. You just give it the you pass it through the ports for the public. You export the decompressor to a public IP with the port number. So yeah, if you don't have a GPU local, it's very, very easy to find compute now with all these AI workloads. It's extremely easy to find. So again, now if the Chia price goes very high and it stays kind of, the net space kind of stays in this kind of band, maybe it might make sense to go to the highest compression ratio. I don't like adding that much compute. I did this math myself, and again, I have this in that public spreadsheet here. When I put in my information on my farm with the right kilowatt hours and how much, I'm at I think 0.6 watts per terabyte on average across my farm. I have mostly 16 and 18 terabytes, but there's a lot of 14s and 12s mixed in there. So for me, C18 was about the same profitability as the other ones, but you can see if the Chia price goes up, then it actually does usually make sense to go to the higher compression ratios. It just depends on how much compute you want to put. I'm already putting, again, a decent amount of compute. My total farm at the end will take about 2 3080 Ti's or so to harvest, maybe a little bit more, like 2.5. So I'll have to figure out. I haven't quite figured out what I'm going to do there, but I'll probably just do a remote decompressor and dedicated thing for all the harvesting on one box, or maybe split between 2 nodes for some redundancy. I also want to make sure that I'll have enough headroom for the halvening, but I'm not doing that yet. Again, I just told you can spin up remote compute very fast, so I can spin that up and add compute, if I need to, and then I'll, later I can figure out, what a longer term solution looks like. So I am playing around with some GPU servers and other fun stuff, but yeah, that's for another day. But okay, well, that was my Chia farm. Hope that was interesting. Thanks.